Welcome to The Explainer. I am absolutely thrilled you're tuning in. Today, we're going to do something really special. We are going to completely break down the towering, intimidating walls of calculus and trigonometry. If you've ever stared at a textbook full of Greek letters and complex symbols and just felt totally overwhelmed, you are exactly where you need to be. We're going to translate all of that rigorous math into intuitive, real-world concepts, what our source beautifully calls baby ideas. Because it turns out complex math is really just a highly organized way of describing the world around us. Here is our roadmap for today. We're going to hit the calculus big picture, differentiation, integration, that weird mystery of plus C, basic trig, and finally, a solid learning roadmap. Let's dive right in. Section 1, the calculus big picture, going way beyond the formulas. So, what does differentiation actually mean? I want you to completely forget the textbook jargon for a second. Seriously, clear your mind of all those rigid definitions. Instead, I just want you to picture something super physical, like a toy car cruising down a road. Because here's the core truth. Differentiation, it's just a tool. If y tells us where we are, the derivative simply tells us how fast y is changing when x changes. I absolutely love the source's metaphor for this. Think of it exactly like measuring the steepness of a road. If your derivative is positive, your little toy car is chugging uphill. Negative, you're coasting downhill. And if it's zero, well, you're on a perfectly flat surface. That's literally it. The derivative is just a measuring tape for change. Moving on to section 2, differentiation and finding the slope. Okay, now that we know what a derivative is conceptually, how do we actually calculate it? Let's take a notoriously confusing concept like the sum and difference rule. The source turns this into pure intuitive logic. Think of it like this. If two toy cars are moving, the total movement is just the movement of car 1 plus the movement of car 2, right? So if your function is x squared plus x cubed, you just differentiate each piece totally separately. Car 1 plus car 2. It's honestly that straightforward. And this brilliantly sets up another really tricky one, the product rule. When you multiply two functions together, you can't just take their individual derivatives and multiply those. No way. Why? Well, imagine you've got a certain number of boxes and a certain number of apples per box. If both the number of boxes and the apples inside are changing at the very same time, you have to account for both ways of changing to find the total change. You're simply counting the change in the boxes and adding it to the change in the apples. That's why the product rule has two halves added together. Make sense? All right, section 3, integration, rebuilding the tower. So if differentiation runs the mathematical machine forward, integration literally just turns the whole machine around in reverse. Let's look at them side by side. Differentiation breaks things down into pieces, kind of like smashing a Lego tower to see how it was built. Integration takes those broken pieces and tries to rebuild the original tower. You start with the rate of change and you work backward to figure out the original amount. Which brings us to section 4, the mystery of plus C. If you've ever stared at an integration problem, you've probably wondered why we always tack on this random letter C at the end. Well, consider these original functions. If your function is x squared, the derivative is 2x. Okay, but what if it's x squared plus 5? The derivative is still 2x. The derivative of a constant number is always 0, because a plain number just doesn't move. But, this creates a huge mathematical blind spot when we turn the machine around and try to integrate 2x back to the original function. Which function was it to begin with? Because that positive 5 or that negative 100 totally vanished during the differentiation process, we're completely blind to them when we work backward. So, we add plus C during integration. It's basically our way of waving a white flag and saying, hey, we rebuilt the Lego tower, but there might be a hidden, constant piece missing that we just can't see. It perfectly accounts for those missing puzzle pieces. Okay, let's switch gears. Section 5, trig and the famous friends. I really want you to view trigonometry not as this endless, punishing list of identities to memorize, but as a tight-knit little family of relationships. Let's meet the group. Think of these 6 famous friends, sine, cosine, tangent, and their reciprocals as just interconnected ways of measuring an angle inside a right triangle. It all stems from good old SOHCAHTOA. Once you know SOHCAHTOA, the other 3 friends are literally just flipped, upside-down versions. It's basically an exclusive club of ratios. And our source beautifully categorizes these properties to make them so much easier to digest. Take the even and odd identities, for example. Sine and tangent, they're odd, which means if you put a negative angle in, that negative sign just pulls right out to the front. But cosine is even. Cosine just completely absorbs the negative sign entirely, making it the even standout. Little tricks like this absolutely save you from having to rote memorize every single line of a textbook. And finally, Section 6, your calculus learning roadmap. Please, whatever you do, do not try to memorize all 36 differentiation rules and 20 integration rules at once. To save your sanity, follow these 6 stages in order. You gotta slowly climb the mountain. Stage 1 is all about mastering the basics, the cars and the apples. Only when you've got those locked down do you move to Stage 2 for basic trig, and then Stage 3 for exponentials. You want to build a rock-solid foundation before you even think about tackling the advanced stuff waiting for you in Stage 6. If you only take away one single thing from this explainer today, please let it be this exact hierarchy. This right here is the grand flow chart showing how all these isolated concepts connect into one elegant system. You use trig to build functions. You measure the slope with a derivative, find the change in that slope with a second derivative, and then you tie the whole shebang together by running the process backward through integration. To sum up that grand scheme, burn these 3 fundamental truths into your memory right now. 1. The derivative is simply the slope of the curve. 2. The second derivative is how that slope is changing. And 3. The integral is just the reverse of differentiation. These 3 facts are absolutely the beating heart of all calculus. Grasp these and you've got the whole subject figured out. I want to leave you with a little something to ponder. Knowing that all this intimidating math is really just an elegant way to measure changing environments, how are you going to look at a toy car rolling down a hill differently today? Will you see the slope? Will you imagine the derivative in real time? I highly encourage you to start looking for those hidden mathematical Lego blocks shaping the beautiful, moving world around you. Thanks so much for joining me to demystify these ideas today. Keep learning, keep exploring, and we'll see you in the next explainer.